see how to create an application in Apex application using Maven. Then there are a bunch of APIs that one can use to develop an application in Apex. Then once we have seen the application development model, then you will see that there's an operator which has an operator lifecycle. Based on that, you can do the functioning or put the business logic in that. And later on, we'll see how to configure those operators to get things running as per the variable conditions. And we'll go through an operator library which is called as Malhar. And finally, we'll see something called as Apex CLI. So this is the place where you can interact with the application which are running. You can launch application and so on. Okay. So application development model. So basically, it has a bunch of components. So the first and most important component is an operator. Operator is a place where you have the business logic built in. Okay? So this is the place where your code is going to exist. So whether it is reading from Kafka or file system, or maybe putting a transformation stage like filter, or anything, any specific business logic that you want to put, that is going to reside in the operator. The other thing is something called a stream. Stream is something, it's a network abstraction which connects between the two operators. So stream is responsible for taking the data from one operator to the next operator. The data might be processed, data may not be processed, and so on. Okay. Now, what flows over stream is what we call it as tuple. A tuple is a smallest unit of data that can flow over a stream. And it's important to stress this point because there are processing engines which are batch-based, which for that, the smallest unit of data is a terabyte of file. Okay. There are engines which are micro batch-based, where the smallest unit of data are maybe a couple of MBs of file. But when we call it as tuple, that is one record. One record in all those files is a tuple. So that is where we say that we are a true streaming engine, where as soon as the data is arrived, we process immediately. Okay? So that is a tuple that flows over a stream. And putting all these things together is what we call it as DAG. A DAG is a directed acyclic graph, which makes sure that the data flows from one end to the next end in a non-cyclic or acyclic fashion. Okay. So that's what the development model, how it looks like. So when we say that we have to develop an application, we need to develop something like this. So we need to create operators, we need to add operators in the DAG, and we need to connect them together. So that's what is the notion of developing an application. Okay. So to do that, one of the very first step that we do, I hope that this text is visible to everyone. So this is a Maven command which one can directly use to create an Apex application. So this is a very preliminary application that it creates, and using this is the first point to get started with Apex. Okay, so it's basically a Maven archetype command which generates a project for you. It has some basic files built into that, and when the project, the Maven command finishes, the output of that particular directory structure looks something like this. Okay, so I'm going to quickly go through a couple of important files which are there. So the most important file is pom.xml. So as you know, it's Maven-based project. So all the project dependencies, all the project compilation stages, and so on, all that is going to reside in pom.xml. The next important file is application.java. And before I tell what is application.java, it need not be called as application.java. It can be anything in name. Okay, it's just that there is an interface which one has to implement, and that will tell that what a DAG is. So application.java tells that how to define a particular DAG. Okay, so the previous application development model that we saw, that can be defined in this application.java. The other sample operator that Maven command creates is a random number generator. So that is just a basic operator that it automatically puts in that project. Okay. The next file is the properties.xml, which is present in this meta-inf properties resources. So this particular file contains how to configure the operator for dynamic properties. So there's a possibility that when you create an application, you might want to run it with different properties, maybe with different Kafka servers, with different file locations, and so on. So this is the place where you configure the application or configure the operators to do the right thing. Okay. And finally, we have application test. So we have a homegrown test framework which is created, using which one can actually run the application in something called as local mode. So this is the mode in which the application is run as a unit test, and you can test the application functionally. Okay. So that is application test. So this is how the project structure looks like when Maven archetype is used. Now, let's go ahead and see what is really part of application.java. So this is the place we are going to create and define the DAG, right? So we have a bunch of APIs which are there, which Apex has defined. And as Amol has been saying that we need to make the life of user and the DevOps team much easier, because we have seen Hadoop can get very messy. So starting from developers, we have a bunch of APIs that they can choose from, and they can use. So the very first API is like a compositional API. Now let's. So this is how the DAG would essentially look like. So it starts from Kafka. So we have an input operator for Kafka. There is a parser which parses that particular data which is received from Kafka. Then we put filters for the words, let's say, for example. And finally, we do a word count so that we have a counter operator there. And the output of that goes to some database. So let's take a basic application here. Now you can see that there are a bunch of operators which are part of DAG. Now how do you do that? How do you actually design that DAG in the code? So the APIs are very simple. So this application.java file has a class which extends or implements interface called a streaming application. And this is an indication to the engine to identify that this is where the DAG is defined. Okay. Now, when you implement it, you need to implement a single method called as populate DAG. Now, in the populate DAG, there are two main methods which one has to use to just define the DAG. So the very first method is DAG.addOperator. So add operator method. So you can see that there is add operator for Kafka, there is add operator for parser, there is add operator for filter, counter, and the output. Okay. All that this particular API does is it takes a class which has a definition of the operator and puts it or registers it in the DAG. Okay. Now once the operator is added, the next stage is to connect them together. Okay. So that's where we have the method called as add stream. Okay. So add stream, what it does is, if you see the first line, the lines. So the first parameter to add stream is the name of the stream. So the line stream connects the output of Kafka to the input of parser. Okay. It's as simple as that. So I don't see that it's too difficult to get a picture of that. But this is, with the simplicity, this is the most powerful API that one can use. Okay. So this is where one can actually construct anything that they want to do. Okay. So this is the first set of APIs that we have. The next API is a declarative API. So open source world is very fond of this particular API. So we have other projects like Spark and others which are mainly based on declarative APIs. Okay. So there are users who like to use the declarative API. So this is for them their own purpose. Okay. So we have something called a stream factory. So we have a bunch of methods being implemented in that. So one of the method is from folder. So it becomes a source of the DAG now. So from folder becomes let's say a /temp folder. Then we have methods like flat map, which does 1:m operation. So for every row there are n rows it emits, and so on. I'll come to this window one later. Similarly, we have count by keys, group by key, and so on. All these methods are there. We also have map, filter, and all these APIs. So these are the standard declarative APIs. All are available as a part of Apex declarative APIs. And finally, we have a method called as populate DAG. So this is the method which is going to create a DAG for you. So all that we saw in the previous slide can be created just that with these APIs. Okay. So that's all possible here. So that's a declarative API. So one can choose that I don't want to connect it. I just want to define the functionality from stage to stage to stage, and that's what they can do. Okay. Connection is all internally taken care of. So that's the beauty of declarative API. It's a small piece of code, but you get, of course, lesser control. Okay. The next API is a variation of the declarative API, which is a windowed API. Okay. Now, event time windowing is a very popular concept recently in streaming world, where your data that is arriving as a stream is getting out of order. Okay. You need to collate all that data, or you need to correlate all that data which is getting out of order, and do something productive out of that. Okay. So that's where the windowing concept or event time windowing comes into picture. Apache Beam is one such project which it's coming from Google, and it's one such project which actually have given a very good notion of how the event time windowing should work. Okay. This is something which is really based on that. Okay. So we have a window method also created so that the stream of data that is coming in is getting aligned to the event time window now. Okay. And there are multiple options which are there. So the event can be various types. It can be session windows. It can be flat windows like the rolling windows and so on. So there are various ways one can have the windows. The next API is SQL-based API, and as Pramod said, we have a preliminary and basic support of that. But this is also another popular expertise that people have, that they know SQL, they want to work with streaming. Why should they really learn about Java and how to do add operator and so on? Okay. So what we have done, we have given them a way to define what they mean by table and run a SQL statement on that. Okay. So if we look at this particular code, so it says that there's a method called as register table. So register table defines a table called as orders with the SQL execution environment. And the definition of that table is that it is coming from Kafka, and that's the beauty of it, that it need not be from RDBMS system. It's an abstract table. Okay, it's coming from Kafka, and to convert that to a row-based format, we say that there's a message format which is CSV. Okay, so that is how the data that is retrieved from Kafka it's getting converted into row time format. Okay. The other table can be defined as file endpoint. So it's basically the file that is representing the table now. Okay. You can also have custom scalar functions like, so this is Apex concat. I've just put it like that because it's a simple thing of S1 plus S2, something like that. But you can have as complex scalar functions as possible getting registered with the SQL execution environment. Okay? And finally, when you have created all these execution environment with you, all you do is just run the SQL statement. Okay? So how do you do that? You have a select clause, and in the from clause, so from orders, this means that the orders table, which is of the Kafka endpoint, becomes a source. Okay? And into sales, that means the sales becomes as a destination. Okay? The Apex takes care of the fact that it takes this SQL statement and converts that to a DAG, and even launch it. Okay? So that's another set of API which is popularly used. We also have integration with Beam. So is everyone aware with Beam here? All right. So Beam is basically a DSL layer over top of all the streaming engines which are there. Okay, you can just a brief about that. Okay, being a Google project, it is being very, very popularly used, and they have come to us and they had asked for integration with them. Okay, so we have something called as Apex Runner with them. So what it allows us to do is any Beam code that you write, any Beam code in the Beam DSL layer that you write, that you can run in Apex. So we have it in place in their repository, and it's all open source. That's another set of APIs we have. This is another point that Amol and Pramod has mentioned about machine learning. So there is a open source project called as Apache SAMOA, which is streaming machine learning algorithms. Okay, so we have integration with them, and any algorithm which is there in SAMOA can also run with us. So basically, it means to say that we have a capability of running machine learning algorithms. It's not that mature yet because SAMOA itself is limited to a set of machine learning algorithms. Machine learning algorithms may or may not need full data set at a time. Okay, so based on that, they have chosen some algorithms which are popular enough, and that very well can run in Apex now. Okay, that's another API which is available. Now this is another very, very important API. Now, till now we saw that how to develop an application, right? Now, to develop an application, we need to add operator to that. How do we add operator? Using the add operator API, but the operator you need to define somewhere. You need to define the business logic and the operator. Okay. So for that purpose, these are the APIs that plays role. Okay. Now every operator follows a certain life cycle. Okay. And this life cycle is very, very similar to your standard JUnit or any unit testing framework lifecycle which is there. Okay. So you have a setup method which gets called at the beginning of the application. We have a concept called as windowing. Okay. So in windowing, it's a micro unit of data. So that is basically a unit that streaming engine uses to manage the data at a rate as high as 1 million events per second. Okay. So it has to have a unit on which the data is getting managed. Okay. So that is what we call it as window. Okay. So the window, when the window of an operator starts, that's what the begin window gets called. When the window ends, that is when the end window gets called. And every operator, when it receives a data, a method called as process is called. So the process is the method that one has to implement to write their own business logic in. Okay. And finally, we saw that operator has to send some data to the next operator, right? So that is where the output emit method of the output port is called. Okay, all these methods are called by Apex engine, Apex platform. So one need not worry about how they get called. It's just that one needs to implement them to do the business logic there. Okay. Now that we have operators API scene, we have application API scene. The next point is we need to check on how to configure the operators. Okay, so operators can be various different pieces of information. So let's say, for example, filter operator. Filter operator needs to be configured with a condition on which how to do the filtering. If you put the condition hard coded in the code, you cannot change it on the fly without going through the complete testing cycle and so on. Okay, if you have it as a configurable property, that makes the life of an developer or even the DevOps team much easier. Okay, so we suggest that you try to make the operators as configurable as possible. Okay, so that is where this properties.xml file comes in. So this is a very basic syntax of how operator can be configured. Now for the DAG that looks, you can see at the top, the syntax looks like dt.operator.input. So this input is the name of the input that we have given in add operator method. Okay, .prop and .topic name. So this topic is a variable which is present in the operator class, which has setters and getter methods. That's all. Okay, so one can configure an operator something like this. Going ahead, this is another very important piece of Apache Apex project which is there. We have an open source operator library called as Modular, and a very large set of them are ready to use in production. Okay, so this is where you can take away some of the overheads that you have while writing a business use case. You need not worry about, let's say, for example, Kafka, how to read from Kafka or how to write to Kafka, or file systems or JDBCs. Okay, all these are present in the Modular library. Not just that, if you have a data which is coming in a definitive format like JSON, XML, that is also possible there. Or even better, we provide something like filters and rules, which you can just these are the operators which you can just configure and use in your own DAG. Okay, so that's all part of open source Modular library, and moreover, a bunch of them are certified by DataTorrent, which is it's free to use there. All right, now we have seen how the application is developed using the APIs, how the operator is developed. Okay, now it's time to launch an application, right? So Apex has given an API called as Apex CLI. Okay, it's not an API; it's a command line tool. So Apex CLI basically allows you to take the compiled jar or compiled binary of the Maven project and launch it on a Hadoop cluster. Okay. So when you have Apex, so it looks something like this. Okay, so you can execute the Apex command. It gives you a console like this. The first important command that is there is launch command. Okay, so this launch command is going to take a path of APA. Now this APA is an output of your Maven project. When you compile the Maven project, in the target directory, the APA file gets generated. So this file contains everything about the project, your own code, its dependencies, and so on. So this is a completely runnable code in Hadoop. Okay. Now we want to make sure that user need not worry about streaming application masters or application master of Yarn and so on. So we bundle all the application master into this automatically. Okay. So these are we call it as STRAM or streaming application master. They are all bundled into here. Okay. And the launch command is basically used to launch an application. So when this is done, the application gets launched on a Hadoop cluster, and a streaming application that too. Okay. The other, obviously, we have commands like shutdown app, which shut downs the app gracefully. We also have kill app. So sometimes there is a case that you don't want to shut down the app because you know that something has messed up. You just want to kill the app. You just want to throw that away. Okay, so just do a hard kill -9 boot. So that is where kill app can be used. Okay, so that's all I have. We have a bunch of resources which are present on the YouTube link. So I think that should be there somewhere. So you can go to youtube.com/user/DataTorrent. So there are a bunch of webcasts and videos being present there, and the documentation is grooming, but it is at very good shape, I would still say. Okay, so you can definitely go to Apex and have a look at that. Okay, that's all. If there are any questions, I can take.